Yep.
Hello everyone, and welcome to my talk, Yeet, Leet with the OSquery, effective threat hunting without breaking the bank. First, a little bit about me. Who am I? My name is Sebastiaan Provost, and I'm currently the lead security engineer at a company called Beacon. I travel quite a lot as well. I like to go to the gym, and you can find me on Twitter or on GitHub with these details. So let me first talk a little bit about my motivation for this talk. Nowadays, at present, there are quite a lot of endpoint detection and response systems, or managed endpoint detect and response systems, or even extended detect and response systems. Quite a lot of solutions, and they're seen as the answer, the one-stop shop solution for your security needs for bigger companies. And given that they're sold to people as the final solution, quite a lot of companies they built their own solution under that name. I've done some research. I found more than 20 solutions, and some of the more known ones are Falcon from CrowdStrike, Singularity from SentinelOne. You have Cybereason, who's kind of a new kid on the block, and so on and so on. Now the thing is, because they're sold as the one-stop shop solution for security needs to make sure you're safe, they also many times sold on quite a high price, and quite expensive. But the price doesn't always mean anything. Sometimes they're quite expensive, but they can be not as good as they deem to be. So sometimes they still miss common techniques and payloads. Now, I want to make sure that you guys know this is not a talk to bash on all these kind of on the solutions. It's more like a talk that's to explain how you can use free tools, open source tools, or inexpensive tools to help complement the workings of these systems, of these DR systems. So today I would like to show you how you can do that with OSquery, how OSquery can help these DR systems to make sure that the things that those systems miss, that OSquery can still try to help you catch those those things. So let's get into it. What can you expect? I first will give an intro about OSquery, then a quick intro about C2 frameworks. Then I will show you how you can use OSquery to yeet the lead to try to kick out the bad guys. I will show some examples about potential alerting and a small sit trap as well. So let's start with the first bit, OSquery. What is OSquery? OSquery is an operating system instrumentation framework that works on many different kind of operating systems, like Windows, macOS, Linux, FreeBSD, and you name it. Basically, if you can compile it yourself for your own system, it'll probably work. It's originally built by Facebook, and basically build it to have greater visibility on the entire fleet of servers. What is server A doing, or who is logged in server A, or on all servers, for example, in one location. OSquery allows you to do that. After a while, they deemed it was necessary that it was maintained by the Linux Foundation to make sure that it kept being developed under a good name as well, and with a different view on it. Nowadays, it's used by quite a lot of big companies like Netflix, Uber, Airbnb, and so on. Now, how does OSquery actually works? So OSquery basically exposes your operating system as a relational database. You can basically use SQL queries to explore that operating system. Now, when it exposes your operating system as a relational database, it can do that in two different ways. So you have either event-driven tables or state-driven tables. The event-driven table is basically a table that has all events that you want to monitor from a certain item. For example, you want to monitor the file events in a certain directory. You want to see either files created, deleted, or modified. You can tell OSquery, monitor that directory for me, and that table will contain all file events that happened in that directory. Now you can also, for example, have process events, for example. You want to know which process potentially have launched or how process got launched. So that's also then, again, in an event-driven table, process events. Now, an example of a state-driven table is, for example, just a table file, not file events, but file. You can query the file table with a path, and it will tell you the result of the query in as a state of that file directory you're querying. So let's say you want to query the file index.html in your home directory. You use a query that queries specifically that file, and it will give you name of the file, and you can imagine. So that's an example of a state-driven table. Now, generally, if you run it on different operating systems, there are a few slight changes, potentially different tables because of the operating system, but in general, all the column names are quite uniform. So normally the column names are quite the same on operating systems, or the values may depend on the operating system. Now, OSquery for certain operating systems has some specific features. For example, Windows, it can tie into the Windows event log, which can become quite powerful because OSquery can parse the data in the Windows event log, and then you can query OSquery to get data, specific data from that event log. Later down the line, we'll see how you can combine this with Sysmon. Now, on macOS, nowadays, since macOS 10.15, it also supports events generated by the Endpoint Security Framework. It's a new framework on macOS that allows you to monitor process events and do an audit on those. And on Linux, it supports events generated by Berkeley packet filter. Now, one of the first examples I would like to quickly talk about, we talked about this before, is file information. So the purpose of the file information tables is to track file states and changes. So as I said before, you have two tables. For state-driven, you have a file table. Generally, it gives you the general information like path, directory, inode, size, permissions. And it's supported on all operating systems. Now, the event-driven table, file events, it tracks time and action changes that are based on configuration. So tell OSquery, monitor that directory for me, and all file changes in that directory will pop up in the table. Now, this is currently only supported on Linux and macOS, not on Windows, but it might be supported in the future. Now, another example of what OSquery can do, it can basically give you a list of all listing ports. So the purpose of this table is to track what process is listing which ports. It's a state-driven table called listing ports. That shows the general information like port, protocol, process ID, family address, and it's supported on all operating systems. Now, if you combine this with the process table, you can do this with the process ID field, because the process ID field in the listing ports table directly translates to the process ID in a process table. If you can combine these, you can basically track, look at the listing ports and directly have the names of processes listed next to them as well. This allows you to track malicious processes that are potentially listening for commands. Another small example of what OSquery can potentially do or potentially show you is pipes. So the purpose of this table is to track pipes that are used for inter-process communications. It's again a state-driven table called pipes. It's just gives you general information like name, instance flags, and it can show you named and anonymous pipes. Now it's only supported on Windows because pipes are heavily used in Windows. It shows some information on Linux, but not as much because on Linux pipes work a little bit different. Now this is useful to detect unusual process communication, but we'll go a little bit deeper in that later on down the line. Now I would like to quickly have a chat about C2 frameworks. Now, what are C2 frameworks? C2 frameworks are basically post-exploitation frameworks. You can use them after having an initial foothold or initial compromise in a network. You can use them basically for previous escalation from that initial compromise, commit execution, pivoting, lateral movement, and you name it. They're used quite a lot in red teaming exercises or red teaming engagements, but nowadays used a lot as well by malicious actors. For example, Cobalt Strike has been repurposed by malicious actors to use them because it's quite easy to use and quite powerful. Now there are quite a lot of more known C2 frameworks, and some of the more known ones are you have Empire, you have Mythic, and Cobalt Strike as mentioned before. And what makes them so powerful is that they basically many times those frameworks support more than one operating system. Um, some other operating systems are agnostic, some support multiple. It all depends on what the creator intended for that framework. Now, a quick example that I want to talk about is, for example, the Empire C2 framework. Empire C2 framework was originally built as a pure PowerShell framework for Windows, but after a while it merged with another project that had almost the same name, that was then again a Python-based framework. And so now combined, it's quite a powerful C2 framework that is pure PowerShell for Windows, but it also you can use Python 3 and higher for Linux on macOS. You can use this, you can deploy this in quite a few different ways, like you have Docker, Kali, or another way that you want yourself, you just have the source code. So it's quite powerful because it's supported by many operating systems, and it's quite easy to deploy as well. Another one of the frameworks I talked about is the Mythic framework. Mythic framework is not necessarily it's not purpose for one or two operating systems like Empire, for example, or 3, but it's basically a cross-platform. You can deploy it on any platform that you want that supports containers, because basically the backend runs in Docker containers and the frontend is web interface, but also runs in Docker container that exposes port 80 or 443 to the public that you can serve on. Now, the Mythic framework is a framework with, in my opinion, a real plug-and-play architecture. What I mean with that, so like I said, every service in Mythic framework runs in a Docker container. Now, if you want to add more agents or profiles to the framework, you can use its command line interface to just install a Docker container. And Mythic knows I need to launch Docker container, and it will automatically appear in web interface as well as a new option. So let's say, for example, Mythic framework, I want to use what they call is the appful agent, not mistaken. It's specifically an agent that can be used for macOS. I install the Docker container with the command line interface from Mythic, and 2 minutes later in the web interface, I can just select that agent to generate a payload. Now, I've shown you a little bit what OSquery can do. Talked a little bit about C2 frameworks. Now, let's see how we can use this OSquery to potentially catch the bad guys. Eat the lead, of course. Now, there are multiple ways to do this. I'll use a few examples, but these are only a few examples of the many ways you can use OSquery to catch bad guys, catch misprocesses, whatever you name it. One of them is YARA rules. You have also file integrity monitoring, you have process events, or, and I'll go deeper in that later, you can combine OSquery with Sysmon, which can become quite powerful on Windows devices. Let's first have a look at the YARA rules. So YARA rules basically their way of identifying malware or files with certain rule sets. They're quite good support on macOS and Linux, and lots of times you can either do it on the command line or you can do it in combination with file integrity monitoring. Now, with OSquery, you can do it's built such a way that it will trigger on the file access create and modify. So we will use file integrity monitoring to monitor for files, and if they match one of the rules, we will get an event in OSquery that we can look for with the query. Now, as I said, it worked with the create and modify file action. During my research, I found out that it doesn't trigger on a move to action. But imagine you have a directory and you're monitoring that directory with YARA rules. And only if a file gets created or modified in that directory, it will trigger a potential rule. But what if a malicious actor copies a file or moves a file to that directory and then launch it? YARA rules would never catch it. So I created a pull request for the core for OSquery to fix that, and this was released recently in version 5. To quickly show you, this is basically a screenshot of my pull request. As you showed, the change is quite trivial, because originally they just checked at the file actions if it was created updated. If it was not one of those actions, it will say invalid action. So basically, to fix this, we just had to move to action, had to add the move to action to that same line, and then after that, it works. Now, what does a YARA rule look like? This is basically a very simple YARA rule I wrote to catch like a stager from the Empire framework. Basically, define two strings that are present in that kind of stager, and the condition is here that only if those two strings are present in that stager, this will trigger the YARA rule. Now, how that work? Basically, I tell Yara, monitor my home directory and use a set of YARA rules, of which one of the YARA rules is the one I just showed you, the example. Now, if I copy, or move, create, or modify a file, that's in this case called empire.divcon.bin, which is a stager, into directory, Yara will see this and will trigger what they call a Yara event. As a result, we will be able to see this in OSquery. Now, this shows that I created and then updated a file in the directory we were monitoring. As you can see, this is an event-driven table. So basically, this table only gets data or rows if an event happens. Now, how would you make sure that OSquery then tells you somewhere else in an alert that this happened? You can basically tell OSquery to configure, to basically tell OSquery to schedule a query every 60 seconds or every 5 seconds even to query that table. And the moment it sees a row, it can save the log file for you, and then, for example, Elasticsearch or Splunk forwarders can monitor the log file, and if it sees a new row, it can put it into their systems as well. Now, let's have a quick chat about file integrity monitoring. File integrity monitoring is quite a rudimentary and basic functionality that can be used to monitor directories and files on any given point in time. It can work recursively as well. It's quite useful. So, for example, if I tell it's okay, monitor this directory, and I add a special character to it, it's a monitor all subdirectories as well. Now, this implementation of file integrity monitoring, this also triggers a move to, which basically tell us that the YARA rules or the YARA functionality has a different implementation for file integrity monitoring than file integrity monitoring itself. Now, how does this work? I can, for example, say to that functionality, like on the macOS, monitor all launch directories from all users. So basically, I tell OSquery, in the folder users, go over every single user and get the launch agent directory and monitor that. Basically, so if, for example, a threat actor places a malicious launch agent file in a directory with any of our users, we will know about it. And this will appear then in the file events table, which I mentioned before, which is event-driven table. And this is what it potentially might look like. Now, how does OSquery know which directories to monitor? That's quite easy. So basically, you tell in a configuration, monitor these directories for me, or this recursive or not. In this case, I want OSquery to monitor my workspace, launch agent directories, and my temp folder. Now, another item I'd like to go over is process events. So as I mentioned before, OSquery has the ability to monitor for process events or process in general. We want to basically monitor process executions. On macOS, we use Endpoint Security Framework for that. And on Linux, Berkeley Packet Filter as a backend for that. FreeBSD is not supported yet, but maybe in the future it will. Now, this functionality allows us to monitor both parent and child processes. Now, this can become quite powerful because you can see any action a process did in this table. Let's say, for example, your company or you is only Mac-based. There are quite a few malware families or threat actors that use OSZ scripts to launch certain actions or to initially deploy a stager. Now, OSZ script is basically the macOS equivalent of PowerShell, So it's quite strong as well, quite useful. As example, there are two malware families that I know of, Hidden Lotus and Lamepire, who basically use OSA scripts to initiate certain actions. So if we monitor with process events for OSA execution, you can potentially catch Hidden Lotus or Lamepire or something else that uses that specific functionality in macOS. Now, as an example, as mentioned before, we can monitor for OSA scripts. Now, how to do that? There are two ways. You can either use scheduled queries or manual queries. So, as mentioned before, scheduled queries can run every minute, every hour, every day, or every second if you want to. So, if you want almost nearly real-time alerting with only a few seconds delay, you would say, I want this query to run every single second, put the data in a log file, and then any other item can pick up the log file and put these alerts or these events in a seam, for example. Now, if we see that OSA script is executed, we can see the potential indicator of compromise. Now, what configuration for a scheduled query look like? As I mentioned before a few times, this example with for OSA script. Basically, we tell here OSquery to query the process events table where the command line contains the word or the characters OSA, because that's how you would launch. That's one of the ways you would use to launch OSA script on a command line. We tell it to do it every 60 seconds, and the parameter removed false basically tells us to not. Once again, the parameter removed, if it's on false, it tells to give us all data, because if you just remove true, it will tell you only give you results if the item is removed from the table again. Now, this is how it would look like if you manually query for OSA script execution instead of with scheduled query. You can basically tell process events table, give me everything you can where the command line contains the characters OSA. And as a result, it will show you the process ID, the path, mode, and also the parent process ID, which might be useful because then you know where is the comment coming from, basically. And that can be quite useful when you're doing incident management and incident response as well. Now, one last example I want to talk about with that can be useful with OSquery is OSquery plus Sysmon. This can become quite powerful. Sysmon is basically a Windows system service and device driver that logs and monitors system activity. It can do with that in a myriad of ways, but some examples are it can monitor for pulse injection, grey pipe, and so on. However, I want to emphasize that with pulse injection, normally you would do that with, for example, create more thread or anything like that. And that's when you attach a thread to a process. But there are also ways to basically use an already existing thread. You can do it by using user APC calls. That's sadly something Sysmon cannot monitor yet. Hopefully later down the line they will be able to monitor that, but it seems to be quite difficult. Now, Sysmon is quite powerful also because when you start it, it stays active equals reboots until you uninstall it again. It's every item it finds while monitoring your system, it saves it as events in the event log under the channel Microsecure Sysmon / operational. Now, why is this used with OSquery? Because OSquery can basically tap into Windows events log. And so it can tap into that channel that Sysmon created. Now, it can pull in all data from that channel, put it in a table, and parse the data in some ways. Now, so basically, you're telling your system, one side you have EDR systems to monitor for quite a bit, and then you combine OSquery and Sysmon on Windows to monitor for a whole lot more that potentially your EDR system might miss out on. Now, one example I could talk about for this is grey pipe. So Sysmon can monitor for grey pipe, closed pipe when you use named pipes. One of the major C2 frameworks that uses pipe functionality is Cobalt Strike. Cobalt Strike uses named and unnamed pipes and basically uses for communication between beacons and sacrificial processes. As example, the default COBOL stack pipe to under shellcode basically starts with msse-number-server. Good threat actors and good red teams basically change the default pipe names so they are not easily recognizable as if you keep using default ones. Now, what would this look like as a result? This is now with a manual query of schedule 1, and the create Python event ID is 17. So basically, I tell OSquery from all Windows events, give me the event where event ID is 17, and for example, that time. And then it tells you the provider name, which is sysmon, what system it came from, so you know what system to look for if it's something bad. And the data field is basically a JSON blob that tells you what's the pipe name, from what process did it come from, and what process did it go to. Now, another example that's quite useful with sysmon is process injection. So we've talked about the Mythic framework before, and one of the agents is the Apollo agents. Basically, agents created in .NET to run Windows. Now, the Apollo agent uses process injection to execute a myriad of tasks. For example, let's say I want to take screenshots from the system I compromised. Then you can do that with the Apollo agent. Now, in this example, I used, for example, Apollo agent to inject myself in a toolbox binary, which is from JetBrains, and from there take screenshots from the system. Now, this is what it would look like if I query OSquery again. It tells me again what system this was on, what the source and the provider name was, and in the data blob, it even gives me the technique ID, which is T1055. Technique name, it tells me what process it injected itself in and what it's trying to do. Now, we've seen OSquery, we've seen two frameworks, and how you can use OSquery combined with other items maybe to try to catch bad guys or try to kick people out. Now, what would the next step be? From my opinion, it would be alerting. You want to be able to alert on these events. Now, alerting is, in my opinion, the next step, because detection is only a small part. You need to be able to empower your security teams and empower your SOC teams to be able to respond on these detections. So basically, you would build a pipeline that allows you to get these alerts as soon as possible, at least these detections, so your teams can respond to them. I'll show you an example as well on how I would use that, how I would do that. Now, alerting pipeline architecture, from my point of view, keep it simple, stupid. Don't make it too advanced, don't make it too complicated, but the more complicated you make it, the more edge cases can go wrong, the more things can go wrong, the more things you might miss out on. You could potentially get unwanted side effects. So a simple architecture would exist out of potentially 4 elements, different endpoint, which potentially a MacBook, Windows laptop, you name it. Then you have a log forwarder, which basically forwards all logs or all findings from OSquery, for example, from the endpoint to somewhere else. Then you have a scene where all that information gets saved in, and then your scene potentially can send out alerts to several communication options. Now, what would this look like in reality? So this is a very rudimentary and simple pipeline from endpoint to alerting. So you have an endpoint running with OSquery, a Splunk universal forwarder, and a log file. Basically, OSquery says all events that it has from scheduled queries in a log file. Now, the Splunk universal forwarder will point to that log file, and basically look, every time there's an event, it will forward that event or that item, that's most times a JSON object, to your Splunk cluster, Splunk instance, you name it. And then on Splunk, you can say, run a query on real time when a new event pops in, and if it triggers certain conditions, then send an alert. It's from Splunk, you send alerts of PagerDuty, it's like anything else, phone, email, to alert your security teams, to alert your SOC analysts from, here's something happening, please respond to something happening on that endpoint. Now, we've now also seen alerting, but that would the next step be. There's no attack and kidnap block. It's not very common that the people always do that. It's coming more up and up the last 2 years, and that is SOAR. Now, SOAR stands for Security Orchestration Automation Response. As you're going to see in the name, it relies on automation. So you have automation, automation, automation. You can do it with playbooks. Now, there are quite a few solutions. Some of the known ones are Phantom from Splunk, Cortex, Alien Vault. But what can SOAR actually do? SOAR can basically do certain mundane tasks that's quite boring mundane for your SecOps teams. So basically, SOAR can help you to improve quality of life for your SecOps teams and make sure that your SecOps teams don't get any alert fatigue. Because the more alerts they get in from detections, if it's getting too much, this will have a negative effect on your SecOps team mental state as well. So basically, SOAR can help you. Now, how it look like in practice? Basically, you have a SIEM, as explained here on the screen, a SIEM that has all events I've seen before. For example, events from OSquery or from some CrowdStrike, something else. And SIEM, instead of alerting on PagerDuty and Slack, it can send those events to a SOAR platform. Now, SOAR platform, as mentioned before, has different playbooks. Let's say, for example, it has a playbook for phishing. Now, a SIEM can, for example, say, here's an event, we have a phishing alert, for example. And then the SOAR platform can look, I have a playbook for phishing. I have to, for example, look at the actual email, run it through a certain system to get better intelligence on potential items in that email, and then do certain actions. For example, SOAR platform can say, okay, this validates quite a few conditions. I need to make sure that phishing from that email address cannot come in anymore. So basically, SOAR platform can do quite a few actions that your SecOps team can do as well. Another example, let's say you have a Windows device that is infected with ransomware. Of course, you want to stop that ransomware from breaking out to other devices as well. So basically, SIEM gets the detection, sends the event to SOAR, and SOAR platform based on playbook can then, for example, say to your EDR system automatically and directly isolate the infected device. This will help you prevent from the infection from spreading. And like this, it's already isolated, and then your SecOps team can potentially look at it and do instant response on a specific device. Now, there are a lot of functionalities and possibilities of using SOAR in the future. These are just a few items, but I think SOAR is definitely something that every good SOC team or SOC should have to be able to improve the quality of life for your analysts and your security operations teams. Now, so today we've seen what is OSquery, C2 frameworks, Yeet, alerting, and SOAR. I hope you all learned a bit. I will gladly share my slides the next week on GitHub and on Twitter as well. And thank you all for listening. Now, these are also some of the resources I used in case you want to look at how I did some of my research as well. Thank you, everyone.